Simple Database Archival Solution, or SDAS, is an open source solution available under Apache License 2.0, which you can deploy in your AWS account now to archive data to AWS. With SDAS, you can archive Oracle, Microsoft SQL, and MySQL databases from cloud or on-prem to S3. With SDAS, you can quickly and easily map the schema of your database, perform validation, and transfer data to S3 for the storage. And that storage could be as long term as your requirement. This whole thing is accomplished via an AWS solution which takes into account AWS Step Functions, AWS Glue, S3, and Athena, among various other services. And this solution is now available in GitHub, and it is an open source. All you need to do is to deploy this solution in your account, and then you are good to go. In this video, I'm going to quickly discuss what this solution looks like and also try to explain to you how you can archive a database through some of the screenshots. Before I start discussing this architecture of SDAS, let me give you a few key features which SDAS is useful for. First and foremost, it supports three of the most popular databases, including Oracle, MySQL, and SQL Server. SDAS is intelligent enough to identify your data types and table schema. It also performs quite a comprehensive data validation. If you have ever done any migration or replication or even archiving of data, you know how useful and critical data validation is. Because if you are archiving your data for the long term, you want to be sure that if need be and if you need to retrieve this data after a long time, the data should be in the same format what it was stored. So STAS ensures that data validation tells you if the data which is being archived is valid or not. You can also configure write once and read many. What it means is that once the data is archived into the S3, you can read it as many times as you want with the help of familiar SQL syntax by using AWS Athena. Okay, so now let's discuss this architecture of SDAS, or Simple Database Archival Solution, within AWS. If you see the diagram on the left hand side, we have an on-premise or the cloud database. So this database could be in your data center, or it could be in your AWS account or GCP project, or even in Azure or in any other cloud. So the origin or the source database location doesn't matter as long as you have the connectivity. And then on the right hand side, we have this S service running in AWS cloud. The S service has two parts. One is the front end and the second one is data archiving. When it comes to front end, it is an intuitive interface through which you can easily manage and configure archives. The front end is built using the Cloudscape design framework, which is a powerful and flexible framework for developing web applications. This front end is supported by several key AWS features, including Cognito for authentication and authorization, API gateway with Lambda function for user operation, and S3 for storing the front end build files. DynamoDB serves as a primary storage mechanism for archiving metadata. Then comes the data archiving part. Archiving of data is primarily performed using AWS Glue, which is a fully managed ETL service by AWS that enables you to extract, transform, and load data from a variety of sources. SDAS includes pre-built Spark Python scripts that are used to transform the data before archiving it to S3. The archived data is stored in Parquet file format, which is optimized for query performance and storage efficiency. Finally, to provide users with an easy-to-use interface for querying archived data, SDAS uses Athena. And as I mentioned before, Athena is a serverless query service that allows users to query data stored in S3 using SQL. So now we know what SDAS does, what are its key features and its architecture. Let's see some of the screenshots to better understand how exactly SDAS performs some of the things which we just discussed. Okay, the first step when you're configuring SDAS is to select your database engine. And as you can see on this screen, what I'm doing is I'm selecting my database engine as Microsoft SQL Server, and then to start the archiving process, I'm gathering other essential information, including connection, database name, database URI, and lot of other things if need be as per database engine. And then SDAS connects to this database. Once it is connected, what, what it does is it identifies the data. And in order to identify the data, SDAS uses a technique to scan the metadata associated with the table. This process is designed to accurately identify the data type and the schema of the table, and ensure that the data is properly formatted and validated before being transferred to AWS. So this process primarily includes running a lot of SQL queries on the data so that when the AWS Glue comes in and writes to S3, it would have valid data. Once this data is identified, then actual archiving process starts, which means to transfer the data to AWS. The archive phase of STS is a critical step in the process of archiving data to S3. So once you trigger it, and it can be done through manually or through the automatic based on some scripting, AWS Glue starts uh, activating, and then what AWS Glue does, it um, performs necessary transformations on the data, including data cleaning and schema transformation, ensuring that the data is properly formatted. Once the data is transferred to S3, it is stored as Parquet files. And a Parquet file is a format and which is in the columnar storage format, and it is optimized for query performance and storage efficiency. And it basically makes easy the archive data to be stored and then queries by using Athena. And Athena supports Parquet. Once that's done, then as you can see on the screen, we have different jobs which are running, and some of them have been succeeded. So this is the data validation step, which will signal that the completeness archive data is accurate. After this process is complete, then STAS automatically triggers a validation process on the S3 side. This validation process begins by comparing the source data to the archive data so that if there is any discrepancy, this will alert us. Okay, and as you can see on this screen, we have various validation results from the different SQL queries. Okay, once you're happy with this validation, the, the archiving is complete, and now you can query the data by using AWS Athena, which is in action behind the scene when you are issuing this select query. And this is basically we call a preview mode in SDAS. So in a nutshell, simple database archival solution SDAS offers you a comprehensive open source solution to make sure that you have some solution about archiving various type of databases, and mainly the enterprise one, Oracle, Microsoft SQL, and even MySQL. It's quite an cost effective way to archive your data on the cloud, because on S3 you can even go with different tiers. I hope this was useful, and if you're looking an for a database archiving solution in AWS, you can certainly try out STAS. If you have any comments or feedback, please put them in the comments. And yes, I will put the link to this GitHub from AWS in the video's description. Cheers. Thanks.